So here we have our railroad tank car gauge kit. Should be in a yellow Pelican case with 8 state asset labels on it. A couple other things just to remember if we're going through this operation, if you don't already have Teflon tape in the kit, make sure to grab some Teflon tape. Make sure that you've got some non-sparking tools for this operation if you're dealing with a flammable vapor, and also make sure that you've considered grounding and bonding on the rail car in question. So let's go ahead and take a look inside what's inside the kit. Right in the middle on top, we've got 2 whips. One of the whips is approximately 10 feet long. You might consider using the 10-foot long whip to connect up into the gauge and allow the other end of the 10-foot whip to hang down the side of the tank car. And that way you could have somebody through a set of binoculars, or if a hazmat technician is working down on the ground watching the ladder, they would be able to see the pressure gauge at a distance farther away from the dome. There's a shorter whip. This whip is about 24 inches long. We definitely want to use this if you want the pressure gauge right up next to the dome to be able to check those pressures. Looking at the 2 pressure gauges inside of here, we've got a low pressure gauge that reads up to 300 psi. This would be applicable if the tank pressures are going to be minimal and read within this range. A chlorine tank car, for example, which may be pressure tested up to 500 psi, we would probably want to use the maximum size pressure gauge we have here, which reads up to 600 psi. On the threaded end, the side that goes into the tank car, we've got 2 size threads here. We've got a smaller thread, which of course needs to have the Teflon tape on it before we thread it into the car. This would be connected to the threaded end of the whip. It too would also have to have Teflon tape, and we can make the connection by threading it there. If we had a larger size thread, we do have the larger thread, and we would simply have to couple these together, making the connection from the smaller thread then onto the whip and putting all 3 of these together if you needed that large size. And there's a couple extra components here, just replacement components for the quick release, or for some reason you had to connect up multiple whips. You've got those extra pieces. All right, so we've selected the components that we need to test the pressures on our simulated chlorine tank car here. Considering that the tank is tested to 500 psi, we've selected the gauge that reads up to a maximum of 600 psi to give us full range of pressures. We can make the connection through the quick connect here, making sure that it's locked into place. We've pre-taped with Teflon tape onto the threads on the whip end, and we've also pre-taped onto our a thread here. We're going to make the connection. Probably best just to protect the threads on the way up to the tank car. We're going to cover the cap here. It's probably best that all of this work is done by the ground team, so that the technicians up on the tank with their limited visibility and their PPE aren't having to make some of these very small connections. We've already sped through the process of looking through the inspection port, checking to see if we've got vapor or liquids inside there. We've made the decision to open up the dome cover, and at this point we're going to begin to remove the nut so that we can access the threads on the vapor line. Now, for the astute hazmat technician, you would recognize the orientation of this dome cover. This valve right here would truly be a liquid valve, but for the purposes of today's training, just the way we've got our camera position, we're going to notionalize that this is a vapor valve right here. And so we'll be able to access through the inspection port. We're able to slide our thread and our whip, our 2-foot whip. We're able to make the couple of turns here till we get a good bite. And then we're able to switch over to a wrench and tighten it down. Once we're threaded in snugly, we can start to take a peek at the pressure gauge. Based on the pressure, we'll be able to determine if there is indeed no vapor pressure inside. Maybe we're at the working pressure, maybe we're at the pressure relief valve pressure, or perhaps we're approaching quickly to the test pressure. That way we can make a decision whether we continue the operation, whether we need to abandon the tank, and look at another tactical approach based on the pressures that we're reading on the tank. So we've completed our operation and we've been able to remove the pressure gauging device. At this point, the best practice recommendation is that if it's being used in a situation where we have a combustible, a toxic, or a flammable, it's best that we just put this device in the tool drop. It'll be disposed of, and we will get a replacement gauge at that time, considering that the threads, the hose are all probably contaminated and corroded, and the integrity is breaking down. So at this point, likely just going to replace the device once it's used.